This video is for the Roxs foldable. We're going to find roots and then the x-intercepts. So Roxs represents the coordinates where the parabola crosses the x-axis. So how we're going to do this, in your calculator, you're going to enter the quadratic into y1. And then you have to set the quadratic, if I can get that to focus a little better, equal to 0. So it will only work if you set it equal to 0. And so once you graph this, let's see here, you can see your parabola. And so you're gonna do second trace 5, and I've already got mine set backwards here. Enter, 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 and it's gonna give you your first intercept. So our first intercept, x equals -1, and then to do your other intercept, as you can see it crosses the x again, second trace 5, and you're going to move the arrow over till you see a little cursor get close to your next intercept. And then you can do enter, enter, enter again, and you'll get your second intercept. And so here's some practice examples. So to do these, you're going to have to set these equal to 0. So on this one, you're going to have to subtract 21 from both sides. So you would get x squared plus 4x minus 21. So you need everything on one side. And so then when we graph it, and so we can see both intercepts where it crosses. So second trace 5, enter, enter, enter. And our first intercept is at 3. And then second trace 5. And then we're going to move our cursor over come on. There it is. To about where the intercept is, and hit enter 3 times again. And we get -7, 0. So x would equal 3 and x would equal -7. Those would be your two intercepts. All right, on this one, we've got to subtract 4x from each side. So we would have x squared minus 4x minus 45. So this would be minus... All right. And so I can still see both of my intercepts. And so here I've got an intersection where x equals -5. Nope. I'm going to move this one over. Oh, there it is. And I've got x equals 9. All right, so on this one, we're going to subtract 7x from each side. But when we do that, since we've already got an x, we're going to get -12x. All right, so we've got x squared minus 12x minus 64. So I'm going to zoom out on this one. Hopefully I can see both intersections. So now I can see both intersections. So second trace 5. So I've got one intersection where x equals -4. And move your cursor over. And then enter, enter, enter. And I've got one where x equals 16. All right, so now we're going to have to move lots of stuff. So I have x squared minus 14x plus 48. All right, so I'm going to zoom in just to make sure Okay, so we do have two intercepts. So our first one is at x equals 6, and then second trace 5, and scoot over to the other one, enter, 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 and x equals 8. All right, so this one all I have to do is move the 28x. So I would have 4x squared minus 28x. And so you can see that I have two intercepts. And so one is at 0, 0, so we're x equals 0. And then scoot over to the other one. Enter, 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 and 7. All right, on this one, you can move either way that you want. I'm going to move the 11x, so I'd have negative 11x squared. Let me fix this. Actually, let's go the other way. So if I subtract x squared from both sides, I'm going to get 10x squared, and then negative 8x, because I would have to move the 8x over. Sorry. All right, so second trace 5. So I've got an intercept at x equals 0. And at 0.8. If you need that in fraction form, that is 4/5. All right, so here we would change it to x squared minus 36. Second trace 5. So here, it popped up here first. So I've got x equals 6. And x equals negative 6. And so to kind of explain what this is doing, if you enter this into your equation, so if I would go here and I would plug a 6 in here, I would have 6 squared minus 36. My y is going to equal 0. So anytime that you plug these numbers into your equation, you're going to get your y is going to equal 0. So just so you understand how all that works. Oops, sorry, guys. All right, so 16x squared, if I move the 9, it would be minus 9. All right, so here 0.75. And then negative 0.75 or 3/4, whichever you need. All right, so in this one, let's move the negative 3x, and then we would add a 1 to both sides. So I'd have x squared minus 4x minus 45. All right, so I can see both intersections. So second trace 5. So I've got one at negative 5. And then one at x equals 9. So that's it for this video.